For experiment 2, the first thing I want to point out is, again, our safety precautions. I have my hair tied back. I'm wearing my safety goggles. Even though I wear regular eyeglasses, I have to wear my safety glasses over my eyeglasses. And I'm wearing some sort of protective glove, whether it's nitrile or latex. In this case, I'm wearing nitrile. I'm going to be using acetone and cyclohexane, and so this provides a little bit better protection than the latex. So for experiment 2, we're going to be identifying some unknowns based on physical and chemical properties. First, we're going to describe the physical properties, whether it's a liquid, solid, if it has any color, whether it's clear or opaque. Another thing we're going to record is the smell. So as chemists, we have a special way of determining the smell. We don't want to stick our face in the beaker, especially if it's something like sulfuric acid that can do some damage. So what we do is called wafting. And so we'll hold the beaker in front of our face and sniff as we're waving the fumes towards our nose. Now this one I can smell right away. This one smells like nail polish, so I know that's acetone. This one doesn't smell like anything, so I can't determine based on the smell what it is. So that's one of the things that we're going to ascertain in this experiment is what is the smell. Another thing we're going to do is the flammability test. Okay, so I'm going to take my pipette. I'm going to treat every liquid as though it's flammable, and I want to take less than half a ml. This is a graduated pipette so that it can tell the volume, and there's a dial at the top. I want to make sure my tip is immersed in the liquid before I scroll the dial. I'm going to transfer that. I'm going to move these larger amounts of liquid away because, again, I want to treat them all as though they are flammable. I'm going to light my splint here. It's a good reason to have your hair tied back whenever you're dealing with open flame. And then I'm really carefully going to lower this down. If it's flammable, even the fumes will catch fire. And it is. So I've taken away the source of the flame and it's still burning. So this is an example of a flammable liquid. Again, I want to keep my match pack away. Okay, so I can test another liquid for flammability. Again, I'm going to treat all of these as though they are flammable. So I'm going to take less than half a ml. If I have too much volume, what can happen is I'll get a really big flame, and that's too dangerous. I'm going to move my larger source of liquid away because, again, I'm going to treat them like they're all flammable. I'm going to light my splint again. I'm going to lower it into my bowl. In fact, this put the fire out, so this second liquid that I used is not flammable. One of the other things that we'll determine is miscibility, and this is really like a solubility for liquids. In our lab, we're not going to have you use your pipettes to remove your reagents. We're just going to pour a small amount into a beaker, and then we'll transfer from that beaker. This prevents contamination of our reagent bottles. So to test if something is miscible, I'm not really concerned about measuring it. I'm just going to add enough that I can see some aliquot into the test tube. You can use the pipette for this, or you can just pour it in. Okay. I'm going to add my second liquid. What I'm looking for here is whether they mix completely or whether I see two distinct layers. So I'm going to pour it in slowly. All right, so this is an example of immiscible liquids, liquids that do not mix together completely. I can tell that because there's a distinct layer separating the two liquids. Let's try another example. Again, I'm not really concerned with measuring here. I just want to combine enough to see. So now I'm going to mix different samples. And again, I want to see if they mix completely, if they are miscible, or if I see a distinct layer. This is an example of miscible liquids because I don't see any distinct layer, and you can see kind of like a strain, like little wavy lines as they're mixing together. But after they are combined, I don't see a distinct layer. So this is an example of immiscible liquids, and this is an example of miscible liquids. These are just a few of the techniques that you'll use and experiment to.